Okay. Okay, so let's start with the operating system basics and virtualization basics we studied last time, right? So let's start with that, and we'll continue details of the Windows operating system maybe a later date in some other sessions. There are not many people joined today, so let's continue with what we can do today. So operating system, right? Operating system, you know, like today, in today's world, we have bunch of operating system working on different devices, right? Depending on the device you are using. Most of the mobile devices that we use today, they use Android or iOS, right? So that is the most common operating system. Apple uses iOS, and other devices use Android, and these are the most common for the mobile devices. But other than that, for the servers or the machines itself, there are many operating systems available. They mainly classify into two categories, which are Windows and the Linux. Now the point is that in old days we used to call it Unix, and but later on the lot of evolution happened, and finally the operating system which is most commonly is called Linux, right? But Linux has so many flavors. Linux is not just one operating system. Linux is like a, you can say, a brand of the operating system called Linux. It has so many different flavors. Ubuntu is one of the flavor, and so Linux will go into a lot of more detail. And this is the Linux. Windows is the operating system, you can say, mostly for the desktop machines. We all the laptops and the PCs we have, it has most of or almost all of them have Windows operating system. But at the same time, for the servers serving the services, and let's say a lot of internet-based servers and a lot of internal application companies are hosting, they mostly use the Linux operating system because Linux is more optimum from the resource utilization perspective and the way hardware resources are being used. So Linux is more popular on that front. Linux is not that user friendly. It doesn't give you as nice GUI as you see from the Windows perspective, where everything is visible. You can just click and get to your desired location. So Windows is good from the end user interface perspective, but when we talk about the heavy load applications and all that, so Linux is better in that perspective. So you can see that these are the commonly used operating systems in today's world. In most of the cases, you know, laptops have Mac OS, and we have Windows servers and workstation. Most of us have this workstation which has this Windows operating system and Windows 11 or Windows whatever. So operating systems, you know that, right? Is something that we use, but we have to keep in mind that this is a very important element running any device, any computing device or any mobile device or laptops or PCs or server that you have. They are actually the kind of the command and control of the entire system that you are using, right? So as we said, right? So operating system is like a brain of the computing device, right? It's very essential software. What operating system does actually, it just manage the hardware that you have, right? In the hardware, what we have normally in the hardware, we have, let's say, laptop or PC, right? It has memory, and it has your programs and files and your data, and you want to go and do something, right? You want to open a PowerPoint presentation, you want to make a presentation, you want to open some program to write some code or whatever, right? So whatever you do, your someone has to give those resources. Let's say you want to run a PowerPoint, so someone has to make sure that PowerPoint application opens up, it's gets some memory allocated to run the application and the program. So operating system is the main thing that controls all the resource allocation within a system, right? Today, let's say right now we are connected to this Google Meet application, right? And Google Meet, as we discussed, is a SaaS based application, but it's still you have to open your browser have to connect to the Google Meet URL, and from the URL, now right now you are seeing this stream coming to your interface. So this stream coming to your screens right now is being processed by and stored in memory temporarily and all that, right? So this all resource allocation is done by your operating system. which you are using, whether you're on mobile device or whether you are on your desktop or laptops or tablets even. So whichever device is it, operating system do all the input and output. You see a lot of things that operating system does. It does the input and output, and or whatever the peripheral devices, let's say keyboard, mouse, or whatever you have connected, it's charges controls of that. Whatever the files you manage storing your files, it's being controlled by operating system. How your memory is being shared is done by operating system. How system resources, a lot of things we don't see and the operating system do internally. So is there any issues happening on CPU level and all that, it alerts internally. So, and whatever the software you install, they are installed on that particular operating system. So operating system is a very important element for any computing device to work, whether it's a laptop, mobile, tablets, or PC. So as we say, right, it's the same concept, right? So it's just controls the resources to make sure everything can work together, right? And you see that we have this CPU and our machine internally have the ROM and RAM and CPU and input and output interfaces and CD-ROM drives and so on and so forth. So this operating system is the one who just controls the processing, and he do all the management for us, right? We don't have to worry about the nitty-gritty details of the hardware, as long as operating system is installed correctly and is using the resource management. It's all we care about the user interface, right? For us, the main thing is we care about is the user interface, how we are dealing with the requirement that we have, let's say sharing a file, opening a file, and so on and so forth. But rest of the things, you see, all these rest of the things are being taken care by the operating system. So operating system is a very important element. So this is have to be very big in the mind, that knowing knowledge of the operating system is very important, especially for the people doing the development and developing and making some application, whether a web-based application or a corporate application. They have to make sure that their user, when they will be coming, they will be using certain operating system. So their application have to be compatible with the user application, user interface. Let's say user is coming with a web browser, or user is coming with certain application, user coming with a Windows application, or user coming from a Linux application. So they have to, when the developers develop the application, they have to make sure that their application is compatible with all the user interfaces, right? And the important thing is that, let's say now a lot of people are doing web development, and they do this they use a lot of these web-based portals to develop the application, and a lot of these portals actually have they show you that how it will look like on a mobile device, let's say Apple device or Android device, right? So knowledge of the operating system is critical, and which operating system your users are using is very important. And essentially what operating system does, it takes control of your hardware and does the resource allocation. Is so as an end user, hardware is abstract to you. You don't need to worry about hardware. It's just something sitting in the background, but you just worry about the user interface that you're dealing with, right? So operating systems take care of everything. It takes all the hurdles away from you. It just give you a nice fancy interface. Let's say right now I'm using Windows operating system on my laptop. I just open this PowerPoint presentation or Google slide deck, and I'm just showing to you, right? And rest of the things are happening in the background, which is taken care by my operating system and your operating system to view it correctly. In operating system, I think the important thing is that the essential thing that we all buy from the shop is the hardware first, right? And after buying the hardware, we install a Windows or Linux operating system or whatever, right? So important thing is that whatever the hardware we buy, so, and after having the hardware, what happened that there is a kernel in the operating system. Kernel is like a resource manager, right? Is and people who are doing the development, they hear this word very commonly. The word kernel is like a resource manager, and on top of that, once kernel does the resource management, right? It takes control of the hardware, and then we can run as an end user application, because as an end user we just care about the application, right, or the interface that we are using. So for us is a web browser or email or WhatsApp or PowerPoint or whatever application you're using, we just care about that. But operating system kernel is the one who is managing rest of the resources for us, right? So word kernel, you have to get some familiarity with the word kernel, right? So as shown in this diagram, right, you see, you have the hardware that we buy from the shop, laptop and desktop or whatever, and we install the operating system, Windows, Linux, whatever, and then Linux and Windows or whatever operating system we install, it has the kernel internally, and kernel takes control of all these resources. And so as an end user, we can come and use our applications, right? So you consider and look at these three things and make sure that you understand that hardware just becomes an abstract layer to the operating system, right? Operating system just allocate the resources as and when needed by the end user, and does all the scheduling like memory, freeing up the memory, like buffering the packets and all that is being taken care by the kernel of the operating system. This is again, I think I don't have to go into detail. It's again the same concept. Kernel is managing all the hardware peripheral, and it needs some software devices, that like we install the drivers just to make sure our sound card is working fine, our gaming display adapter is working fine and all that. So that's being taken care by the kernel of the operating system, right? So all the all the hardware control, and on top of that again the file system that we use, and the processes scheduling, which process has to run, which process can be killed when it's done its job. So operating system do a huge and tons of work in the background, which you even don't see. Even everyone's PC or device right now is doing a lot of work, and it's processing, especially on the mobile devices. You see, we have so many applications, and most of the applications keep running in the background, and our operating system of the device constantly allocating resources, deallocating resources, in freeing up the resources, and it's making sure that whatever the resources, CPU, memory available within the device is being used in an optimal fashion. Eventually what happened that some people open too many applications, and device and becomes so overloaded, device is not able to handle that load, and eventually devices crashes, right? So that operating system does it best to avoid device crashing, but it happens sometimes, right? If you just put too many applications. So all the control is coming from the operating system, and these are some of the interfaces we all aware of, like this is uh, most likely, I guess it's an Android phone, because it's showing Google, a lot of Google application. It's not necessarily be an Android, I guess it could be iOS also. And this is Mac, OS running on a Mac laptop, and this is Windows running on some laptop. So this is just the interface that we all are used to of, right? We all use, and we have seen, right? So these are the common operating system that we use mostly, and some of you are very much familiar mostly with the, I guess with the iOS. People are very familiar because a lot of people use iPhones, right? So this is very common. Android, a lot of people use Android, this is very common. And Microsoft Windows are very well known because we all use, or use in some cases. But other than that, Mac OS running on Mac laptops is also very famous. And as you said, on the corporate side, when we build professional servers, mostly they are running some flavor of the Linux, whether it's a Ubuntu Linux or other Linux. We'll read more on Linux. It's more, what are the common Linux servers types or categories. And here you see that on the desktop side, mostly we have Windows and Mac. Sometimes some pro level people who are feel more comfortable with Linux, they use also Ubuntu Linux for desktop, but they are very few, maybe just 1 or 2% in the world, I would say, mostly using Mac or Windows operating system on a desktop level, right? On our home devices. Mobile is simple, just two operating system running on a mobile. And when we go to professional server, these are the most common one. Mostly are running Linux, as I said. Some are running Windows because they are, for some services, Windows is very good. And server OS, when say server OS is difference between desktop and server. Desktop is like a plain machine, just running resource allocation to memory, CPU, and servers is the one, actually is the machine or the device, or which is serving tons and thousands of devices. Let's say you are connecting to CNN.com. CNN is running a web server, right? So it's required some special processing just to make sure millions and zillions of the requests coming to the CNN.com server can be handled, right? Let's say some WhatsApp must be running tons of servers. Google Meet must be running tons of servers. So the servers, actually, operating system the special software, just to make sure that they can do the resource management at a scale, because our home devices are just, how many, what we normally do, 10, 20 browser session we open at the most, right? And we open few application, but servers are designed, or server operating system are designed to handle millions of requests. So it's just an operating system, but only thing is designed to for the scalability, right? To make sure that various users can connect, billions and billions of users in larger deployment can connect, and a still server can serve it without crashing, right? So this is the whole idea of the server have some special hardware and the software characteristic, just to make sure they can meet the scale, right? The large scale deployments concept. Desktops are not meant for large scale. We can just use the limited resource, we can just run few application and the browser, and after eventually it dies out, right? So this is the main difference. Otherwise, concept perspective, desktop and server are similar, that they are like a machine and running a computing device, or like a PC normally running a operating system. But server operating systems are meant to serve huge number of user base. So I will not go through that. You guys can read this later on when I share the slide deck. Is just desktop and servers, or desktop are for home users, or servers to serve the large scale user base. Last time we studied about the virtualization. Virtualization is just to make the virtual, just to make one device and divide it into many virtual smaller pieces, right? So that is the main concept of the virtual, and this concept is applicable for the servers. We can have one hardware server, and you can divide into many PCs or many machines, or you can do it for the networking devices, as we studied last time, the switch, router, firewall. You can also virtualize them depending on the need. Not everyone needs virtualization, but virtualization is definitely is a great technology to make most best and most on the best efficient use of your machine or resources, right? So let's say you have one PC, right? Most of the time your PC resources are underutilized, so you can, let's say, make two virtual machines in the same device, right? So that will help you to optimize your resources, because you can have multiple resources being used at the same time, and you are making best use of your hardware that you have purchased. So, and virtualization is a very critical concept for the cloud computing, because cloud computing, we studied last time, cloud computing is like, normally we rent a server from the cloud, means that Google or Microsoft or someone, they rent you servers, right? So this server renting normally is called the cloud computing, and cloud computing heavily uses the concept of the virtualization, where they build a server, they buy hardware, they on the hardware they can build, let's say, hundreds of the server, right? So one physical hardware PC, you can say CPU, memory, RAM, and they have built you various servers on that, just to make sure that hardware is used to the best of its capacity, right? So normally the way virtualization works is that you have the server hardware. So in the bottom is a hardware layer, and then you run an operating system on that. And normally this is the host operating system, and then after that you can run the hypervisor. Hypervisor is an abstraction layer, right? Hypervisor is an abstraction layer which actually says that I take control of hardware now you can have multiple operating system. You can have 5, 10, 20. One machine is running Windows, one is running Linux, one is running Ubuntu or something. So we'll read more. I think virtualization will have a separate session again, more on detail, probably on this one. But today I'm just giving you a very high level that virtualization is a super important concept to just make sure that hardware, it can be used in a most efficient way, where we can make the virtual instances of the different operating system, right? And this is a very key concept for the cloud computing. So I think I'll pause it here. I think we'll go more on this one probably when the Shahid will join. He is expert. He's been he's in UK. He's working in Amazon Web Services, AWS, as an architect. He has great depth on that. I don't want to steal his session, so I will share this deck anyways with you, so you guys can be prepared for the next session. So, but today, what we can do, I think we can continue our discussion. And last week we couldn't go through the slide deck of the cybersecurity, right? So I think we can continue on cybersecurity because we didn't do it last time. But before going to cybersecurity, I will take a pause here, and if someone has any question on the virtualization basics or the basics of the operating system that we just quickly reviewed today. Okay, if not, then we can start with cybersecurity. We couldn't do the slide deck last week. Yeah, it was all discussions. So discussions are good, but yeah, but important thing is to understand the core concepts also, right? Because cybersecurity coding, as I said, there are few core skills that everyone should know, especially going forward. Everything is getting digitized, everything is on the internet, everything has connectivity. So cybersecurity is becomes becoming more and more relevant now, because more you get digitized, more we have comfort with new applications and new things. We are actually, what we are doing, we are increasing our risk, right? We're increasing the cyber risk, because more we connected, you see that more you are connected, more you are getting more requests for the spams, right? More SMS spams, more email spams. So our cyber risk increases when we get more digitized. And you can see in the future, for sure, there's going to be more and more and more digitization happening, more automation is happening, more artificial intelligence tools are coming, robots coming. So they all part of the digital ecosystem, right? So more digitization will happen. There's a more appetite for the hackers and to attackers to attack and take control of the resources, and maybe ask for ransomware sometime. So what we are doing essentially when we are getting more data is actually we are increasing our risk profile, right? So we are increasing the threat risk, we are getting more exposed. So at the same time, having the base understanding of the cybersecurity, to make sure if I'm a developer, I make sure that my code is secure. If I'm developing a robotics thing, I have to make sure that how it is being protected from someone misusing my robots. And if I'm doing an IT manager in a corporate environment in a company, I have to make sure how my IT assets are being secured. So regardless what we do, we're gonna do something in data space. So we have to make sure that whatever we do, we have to make sure that my product or my services or my offering has the data security, right? So this is what it is, right? So cybersecurity essentially is a practice of protecting systems, not only systems and networks and programs, right, from data attacks. So whatever you do on a data space, protecting it just to make sure it's not being misused. This concept is called cybersecurity, right? And cybersecurity is not just for corporation, as I said, it could be for anything. And what I see in most of the cases now, everything we use is start with some sort of application development, right? Someone writes a code, and whether it's a WhatsApp or some corporate application, someone writing a code. And what we have seen, and this is what most of the cyber experts are realizing, that when coders are doing the coding, that time actually code is malicious, actually is because GitHub repositories and some other repositories, and sometimes people reuse other codes which has some malicious virus inside already, right? So they have to make sure that when they are using the code is secure, is been tested against some tool, and make sure that when they are doing the development, their application is good to use. So this is what it is, right? So cybersecurity essentially is protecting your digital assets and digital, whether it's a system, code, programs, whatever it is, right? So how it starts, right? So what happened, essentially, you have to look from that perspective, why people do cyber attacks, right? I mean, are the bad people? They are not always the bad people, right? I mean, if you look at this slide right now, right? So there are a lot of motives for the cyber attacks, right? Or hackers, they try to hack to other systems. Sometimes it's on nation level, right? So what happened that your country or some country has some anomaly against some other country, and it's because of the political reasons or geopolitical reasons. So nations have something against some other thing, and they try to attack their assets, right? And we have seen sometime that This is very common between India and Pakistan. Their hackers are trying to hack each other's site, although they do nothing other than just sending few messages, and after that, site recovers and they try to secure it. And same thing happened in some cases. A lot of people take the name of Russia and Iran and all that on the cyber world that they are making some attack, but sometimes it's just fake propaganda. Is not always the case. But essentially, yes, this is a tool now. Now, I think in Pakistan also they started using the word fifth generation warfare, right? The fifth generation warfare is on a cyber level where there could be some nations attacking other nations and trying to sabotage their digital assets and digital presence, because everything is connected. As I said, is more comfort at the same time is more risk. So there are some attacks sometimes generated by the nation level funded attacks, and the nations hire criminals, cyber attackers, and they attack other nations just to break their systems, right? Sometimes they are criminals, right? So sometimes these attackers are plain criminals, right? Just like a criminal we have in everywhere, right? Criminal, what they do crimes just to make their everyday living, right? They steal money, they theft money, they do the bank robberies and all that, right? There are criminal people doing the criminal activities, and that's the way their lifestyle is. That's how they make their living. They make a profit from the criminal activities on the internet, right? So there are cyber criminals, right? So these are the bad people actually. Mostly these are the most bad people who, because they do it for the money, they don't care, they have no ethics or anything. And that's where the most of the ransomware attacks is happening, right? That's where we are mostly protecting the cyber attacks for the corporate environment. Most of the ransomware are happening in today's world, mostly because of they ask the ransom money, right? They steal your data. Let's say you have some critical data, hospital data, your banking data, and whatever. And they say that if you don't give us the money we are asking, we'll release all the credit card information of your users on the internet. And so they threat you and blackmail you to get the money out of you, right? So they do it for their profit, and this is most common. At the same time, there are some hacktivists. They are do it some ideologies. Their motive is not to make money. They just want to convey some message, right? Some idea. They are whatever the ideology they are following. They're trying to convey that ideology, and this has been seen a lot, especially during this Israel
You tell us.
during this Israel-Palestine conflict. We have seen it a lot, right? A lot of activists, they're trying to communicate this ideology, and it happens, right? So this is another motivation for the some of the people to do the cyber attacks. And again, there are some terrorist group. They do terrorist activities. They have very extreme ideologies, right? And they do it for their sake. And a lot of time, actually, most of time, recently, actually, in recent years, we have seen just young kids sitting in the school and university and their homes and basement. They're just doing for the sake of thrill, that let's, and they are good at what we do, right? And they do a lot of experiment, a lot of information available freely on the internet. They go through those tools and they learn few things, and they try to hack into neighbors Wi-Fi or some website, a school website or whatever, right? They do it just for the sake of thrill. And this is also common. They are smart kids, I would say, right? So this, they do it for the sake of satisfaction mostly. And sometimes within the organization there are people, right, which are not happy with their bosses or with the company and company policies, or sometimes they are discontent employees, right? And sometimes discontent employees, because they have access to the information, they are sitting in the organization, they are part of the company, and they have given access to the certain files or resources or application to do their day-to-day job, right? And these people are the very much have access because they are giving access because they are trusted, right? But they sometimes they are not happy with the company policies or their bosses, and they do bad things. So these kind of damage they cause to their digital assets. Sometimes they delete the files, sometimes they do bad. So this is coming from the insider community, right? So these are just the current slide. These two are just the same thing explained in different ways, right? So these are the threat actors, you can say. In the cyber world, we call them threat actors. They are the one who are doing the digital attacks. There could be many others, but these are the main categories that you need to understand. And I would say the most of the cyber world we do against these cyber criminals, actually, right? Because they are the criminals who are trying to get into your organization data, and they want to get access to charge you money or ask you money or ransom money, and they threat you, and there's no guarantee that if even if you give you money, they will not do it again, or data they already have got access to, that they will not leak it. So it's a very dangerous thing to get attacked. And depending on the severity, as I said, banks and hospitals are most severe because they have very critical information, very private information that should not be accessible by anyone else authorized. So, and that's where our most of the job of the cyber experts are there, right? Is to reduce or at least mitigate attacks from these criminals. So attack service, what attack service is that when they come to attack, what they attack on actually, right? So if cyber criminal is coming to attack a digital asset, what potentially they can attack on, right? What is that they can get access to? So what happened that if you look at it, right? So they get access to your servers. Let's say you have a web server, a banking site, website, right? Let's say hacktivists come and they go for this web server, whatever the front user is saying. Let's say uh, 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 someone come and get access to someone's website, right? So let's say India, Pakistan, commonly they have this rivalry. They go to each other web server, common website, government website. They get access to the front portal of the website. They change the message on the front portal. So you see that instead of X, it's coming as Y and so on, right? So they access your website. The criminals comes and access your website. Second thing, most important thing, they got access to your critical data, which is not probably on the main front portal. It's in the backend data, which are the credit card information or health information or any critical information is there. So they are after your website. Their criminals are after your data. And sometimes what happened that they check the ports, because the way they get access to data, they check whatever the free ports or open ports, I would say, on the server, and they try to gain access to the server through the open port. That's the reason when you read through the server security or operating system security, is important that if you are not using a port, block it. Let's say if you have a web server normally use port 80 and 443. Yes, you have to open those port 80 and port 443, but other ports you have to block them. If you're not using a port, block it. So the criminals cannot get in through that port, right? It's like a window, right? uh, if you don't need a window, don't have a window, because window is gives access to the people, right? Let's say you have a home with bunch of windows. Yes, it's good for light and everything, but at the same time it gives access to the thieves, right, to get into your house. Your domains, let's say you have certain domains registered, so they try to come to access your domains. Let's say you have a company called ABC, so abc.com, so they will try to register a domain which sounds similar to like ABC or something like that, right? And they will try to steal that domain. And they are after your brands, very important, right? If a brand is famous, let's say you have Adidas or these sites, right? Everyone, Nike, Adidas, everyone goes on these brands, and Coca-Cola, Pepsi, whatsoever, right? The big brands, people try to malign their brands, right? So they try to make sure that your brand gets some disruption with their activities. So these are the attack surface. When we say attack surface, what potentially can be attacked? Your servers, your files, your data, your domains, your brand names. That what hackers try to get access to, and they can do malicious activities on these things. So these things are called threat surface. What can get attacked, right? It could be the site that you know, because let's say you have a website, you know this is your website. You have a data, you know this is data. Sometime what happened that there is some data which actually is there, which is critical, and sometimes even organization or IT admins forget about it, right? So this is some unknown data which hackers can use it. Impersonating attack assets, they can take access to someone and just to try to pretend they are. So these are sometimes third party assets which are not organization asset, but there are some third parties which are kind of essential to run the business. So these are the commonly attack surface, right? So these are the possible ways an organization can get attacked, right? Also, this is also called attack vectors actually. So this definition is important, that what things can I get attacked on, and this is my attack surface or attack vector. I have put a link here, and you guys should review it. And this is a small video about the difference between the public web, deep web, dark web. This concept will come commonly, especially for the cyber professionals. Public web, that is very common, right? Let's say I go to cnn.com. This is a public web. Anyone can go. That's fine. No issues with that. Deep web is actually the one where the 90% of the data is there. What is deep web? Deep web essentially is like a password protected data, right? Let's say your Gmail account. Your Gmail account should be accessible to you only. It has your emails and files and maybe pictures and so on, right? But it's only accessible through the username and password that you have set in your Gmail, right? And most of the critical information, let's have a banking site, data and all that is protected through username, password, and some multi-factor authentication or SMS tokens and all that. So this information is called deep web, and this is where the critical data is there, and this is fine. But what happened that there is another category called dark web. This is where the criminals are there, right? This is where all the bad people sitting, and when people hack someone's site and they threat you that if they don't give them ransom money, they will release on the dark web. And that's where the cyber criminals or the bad people sitting and exchanging the information and doing all the bad activities. A lot of, it's not just about the money. Sometimes, that now is getting worse and worse and worse. A lot of bad people sitting there, and a lot of people are talking about a lot of bad things, suicidal attacks, and so on and so forth, and providing counseling and guidance how to kill yourself. And so much bad is happening these days, right? So essentially, dark web is a bad thing, and dark web is where the criminals are there. Dark web is the one that's where they exchange a lot of bad information, and that's where the lot of exchange of the money and bit over the bitcoins and so on and so forth is happening. And that's where actually especially as a cyber professional, you need to know, understand about the dark web. And dark web is not accessible normally through our normal browser. Let's say we have Chrome, or we have Firefox, or we have anything else. So dark web is not just accessible. You have to use some special browsers. Normally they called Tor browsers, and these are the Tor browsers. They have a special access to those underworld, I would say, right? This cyber underworld. So you get access to that. And this is very I would say tricky, in a sense that don't go it for fun, because they normally get access to your information and they can misuse it even if you go for fun. So it's not for good people, it's for bad people. So go through this video. It gives the explanation of these public, deep, and dark web, and so you understand better, right, what these things are. So normally what happened that what type of attacks, right? Attack tactics, we call them. No, we don't normally call it techniques. We call it tactics because it keep changing and all that. What are the common type of techniques or tactics people normally use? Eavesdropping is very common, where someone just sit in the middle and try to listen to the conversation, or let's say listen to your exchange of the username password. You're trying to log in to an application, you have some username, you have some password, and you're trying to submitting your username and password, and sometime someone sitting in the middle and trying to listen to your username password so it can get access to your username password. If people are using the plain text simple without encryption, then they can get access to this information. This eavesdropping type of attacks is very old, but still it works sometimes, right? Second most common is like phishing attacks, right? Phishing is very common. We have seen all type of phishing, especially uh, phishing is common for the emails. We see all type of these bad emails coming to us, asking us to click on certain links. And the moment we click, they install some bad software in our device, and they get access to our device. And so phishing is bad. Sometimes they send us SMS, right, with some message that your parcel is waiting, your this thing is waiting, your delivery has come, please click on this. So phishing is bad, whether it's an email phishing or whether it's SMS phishing. And normally there are there are different categories. Phishing is phishing, but essentially, if they are trying to access and lure some CEOs and CXOs and some top level guy, it's called whale phishing. It's the same thing, but the only thing is that it's targeting some high executive in the company. It's called whale phishing, because it's like a whale, right? It's a big guy on the company. If they get access to his account, he must be having access to some lot of critical information, lot of critical company decision making, and so they can get good access. Let's say if they get access to some ordinary employee, they will not get this much information, but if they get access to some financial leadership or some CEOs and CXOs, then they will definitely be getting access to a lot more data. So for CXOs, they do special planning. This cyber criminals, they make sure that they give them a phishing image in a way that's attractive to them, right? And sometimes people just go down, download the things, right? And they just download the stuff. Uh, and a lot of site people go and download, especially download the movies and download some software. And this software sometimes has malicious content inside that, right? So this is important that drive-by downloads, Trojan horses, botnets, they are the small software. They come by default with these untrusted site downloads. And denial of service, brute force. Denial of service is just attacking someone, some website or some data in a way that it becomes inusable. Let's say I have a website, and this website is hosted somewhere, and someone is trying to bombard it with so many web requests or the so much traffic that my web server cannot handle it. So this becomes like my service is denied. I cannot serve to anyone legitimate user coming to access my service, because bad people have sent so many requests that my server becomes so busy it cannot process any legitimate request. So some lot of people do this thing. Let's say this CNN or the big sites, they have a lot of security, so they cannot uh, break their servers easily, right? So what they do, they start sending this denial of service. They have criminal people sitting across the world. They agree that okay, on this time we'll attack CNN.com or whatever the site they're trying. They send so many requests to the site, and this site becomes down, is become inusable, or it cannot serve the any legitimate users. So there are a lot of attacks. You guys should read it all. I have given the links here. You see, these are the links. They will give you different ways people attack. Like sometimes this is also very interesting. Actually, I like this one actually. Cryptojacking, right? If you know that cryptocurrency requires mining, right? You do the mining in cryptocurrency, means mining is that you need a lot of CPU powers, right? You need bunch of CPU powers, and you need a lot of compute powers to do the mining for the cryptocurrencies. And a lot of time people have to build big data centers and servers. A lot of smart hackers, what they started doing is that they see that the bunch of people like you and me on internet, who have laptop or PC or desktop, and we are sitting in our homes and we are not always using our machines, right? And what we do, we sometimes not log into our machine, and at night our machines are just idle, right? We don't let a lot of time, we don't shut down the machines, we just leave them open. And what happened that these hackers, they through the drive-by downloads, or through other ways, they install a small software in our machine, so that they start using our machine as a compute power, right? When so you will sometimes notice that even though you are not using your laptop or machine is running, the fan is running, and is getting heat up. So sometimes these hackers are using as a your machine, and as an extra machine, right? And they are doing the crypto mining in the back end, although it's not doing anything, apparently anything bad, but you notice that CPU is busy, CPU is not functioning to the full capacity, or you're not getting right performance because someone else is using part of the CPU, and in the back end they are doing cryptojacking. This is very smart, I would say. So we have to make sure that we keep our laptops and PCs clean. The software which we are not using, we have to delete them, and make sure that make a habit. If you're not using your machine for a long time, let's say at night or something, shut it down, right? Ransomware, just people just ask for money, for because they need money, and they are the people who don't want to do any good job, and they want to make money, easy money, I would say. So these are the real bad people, right? So some of the ways, a lot of technologies are available, because these are the attacks people do, but at the same time, there's a lot of mitigation happening. These are the technologies people use, especially the corporate level or enterprise level. A lot of corporations spend a lot of money to make sure they are being protected, their asset being protected from these attacks. So they deploy firewalls, they have endpoint solution, antivirus solution, vulnerability scans, assessment, penetration tests. So we'll read through some of these, but that's what the cyber security professionals do. Actually, they use these tools to protect the attacks, or bad people coming to their environment using these technologies. So as a cyber security expert in an organization, you typically work on these tools and technologies just to make sure that you're getting protected from these bad people and attacks they're causing to your organization. This is your job, to learn the tools to save yourself from these bad guys. Any questions on that so far? So we have seen, yes, Umar.
I have a question about the OS. How hackers request so many requests to the servers, and how organizations deal with it.
Yeah, very good question. So this falls into denial of service attack, right? So what happened that denial of service attack, you have a server and you have so many requests, millions and zillions of the requests coming. Definitely, your server cannot process. So eventually, your service is down, your web server is down, or your web page is not reachable. So definitely, there are many technologies available, but the best technology is because what happened that let me give me a second, 1 second. So what happened that give me let me open my annotate mode, right? So I can do the draw something for you. Give me a second. S- So here we are talking about the denial of service attack, right? So what happens in denial of service attack? Uh, so you have a web server, right? And this is your server, right? This is your web server, I would say, and that's where that's the way server is connected, that it's connected to internet, or right, and that's where the users sitting at home or offices, they're trying to access this web server. And normally what happened that you are connected to your ISP, right? Similarly, everyone is connected to their ISP and end user as well as the service provider. Let's say in this case, the service provider is the this web server side, right? This is the service provider. So if tons of requests coming to this server dies. So normally what happens that uh, for the heavily utilized server where tons of requests are coming, and it becomes essentially uh, a denial of service attack. So what happened that normally the way the technique they use is that the internet pipe that you have from your ISP to your data center, they normally overload this pipe with so many requests, right? And the way hackers plan it, that they will set up a time, they will say across their dark web community that okay, at this time, let's say everyone in the world globally go and attack this server, right? And normally what happened that your pipe to the ISP, let's say, is 1 gig connection to the internet, or you may have sometimes you may have 10 gig connection to the internet, right? It all depends what type of connection you have, and this connection get overloaded. But what happened in your ISP itself, right? Your ISP is running a backbone, right? They have bunch of many servers, and they can see the where the request is coming from. Normally ISP internally, the mitigation comes from the ISP network. How the avoidance of the DOS attack comes from the ISP network, not from your side, because you just have a 1 gig pipe, maybe a 10 gig pipe. But within the ISP network, they have hundreds of gigs, right? And they sometimes have even more. So within the ISP network, they deploy special technologies. So DDoS protection comes as a special service. It's called actually denial of service. It's called distributed denial of service. Extra D comes with distributed. So distributed denial of service means that across the globe, this attack is happening, is distributed and coming to attack something. So what happened that your ISP, normally all the large ISP have a service offering called DDoS protection. So they deploy some special softwares, special tools, and special technologies, and they can see that if this is the normal behavior that this server gets, let's say 1 gig traffic, now it is getting 10 gig traffic. Something is wrong with this one, and they have some special tools which can say that yes, now this site is getting attacked because I am seeing some abnormal traffic behaviors and abnormal traffic patterns. So based on the technologies deployed by ISP, they can see this attack, and they see the attacks, they see that this is abnormal behavior, this is sending way more traffic than normal, and they can block these wherever is generated from. So, and this happens within the ISP network, right? So since it's blocked where it's coming from, and they have some technologies, so ISP can block within their network, so it will not reach to this one. So whichever is generating the abnormal behaviors, for those traffic will be blocked, and for normal users can still access it, because they will see that this user is generating, let's say, 1 million requests, right? And the normal user, which, let's say, I'm a legitimate user, right? I'm sitting at my home, I'm trying to access. I will not generate 1 million requests. I will generate 10, 20 requests. Let's say I'm doing a transaction or website or web page or whatever, right? So this is the way technology works. It's a DDoS is the mitigation protection, and that's how it tried to save. And for DDoS attack or denial of service attack, mostly the protection comes from the ISP itself, not the, let's say, CNN.com will take a service from the ISP, which will mitigate and protect. I hope it's clear. It's a little bit more clear now. So yes, Abdurrahim. So from the firewall perspective, the way uh, firewall is give you protection for sure. Let's say you have a server here, web server, right? Let's say your web page. So what happened there, and this is your corporate environment, right? Say, right, this is your company. So normally what we do, we install a firewall, and firewall do the security, but denial of service attack is not the firewall job, because denial of service is just killing this pipe in between, right? So firewall cannot do anything. Firewall can do the security of the traffic coming to, let's say you have a web server, you have a database server, and some hacker is trying to gain access. You have certain ports, right? Let's say your web server works on port 80 and port 443. This is a standard port for the web-based services. But let's say you have an open port, let's say port 139. I'm just arbitrarily picking a number. So where you can have a firewall. When the traffic comes to the firewall, whatever traffic going inside your network, this firewall can see that what is allowed, what is not allowed. Let's say firewall can say that, okay, if traffic coming from here going to port anything other than port 80 and 443, drop it. The firewall will make a drop right here. So firewall will not allow this traffic to go to inside servers. So firewall will say that, okay, yes, I have a web server, and web server people from the globe coming to this port 80 and 443, yes, I have to allow that. But anyone coming for on port 139, I will drop it right here. It will not reach to my server. So firewall actually do the inspection, traffic inspection, and try to drop the traffic which is not allowed. That's the main purpose of the firewall, to provide some level of security. Firewall cannot secure every single thing, but firewall do the lot of security, because it's meant to do the firewalling, means that it meant to protect you from unauthorized traffic. So you can, depending on the firewall policy, you can have a policy to say that certain traffic is allowed, certain traffic is not allowed, and in someone trying to access the traffic which is not allowed, so firewall will drop it right over here. It will not pass it on to the your internal network side. So firewalls are one of the key element, I would say, from the cybersecurity perspective. From the network security perspective, firewall provides you the first level security before traffic hits your network, right? So the way it happens is that you have your internal network, and this is, let's say, internet, right? This is internet. This is your corporate network. So you have a firewall here. Normally you put a firewall. Sometimes people have the firewall inside their network too. That's fine. But at least whoever trying to gain access to your internal resources, first firewall will check that if that access is allowed or not. If not, then it will drop it right here. It will not go inside, which is good, right? So that was the role of the firewall, and that was the role of the DDoS we studied, right? How the DDoS works, how the firewall works. So now we read and we studied about so far about the attacks. What is the motivation for the attacks? Why people do the attacks? There are good reasons, bad reasons, whatever, but there are motivation. Most of the time is the bad reason, is the money or the profit or whatever. And how and what type of tactics people use to gain attack? They do the spamming, they do Trojan horse, they put some inside some malicious code in your machine, so they can get access to your machine. and this is normally the way they get access. And we studied about the threat surface technically in an organization, what can be get attacked, that needs to be protected, and that could be your anything digital asset. It's not only the data, it's sometimes the URL domains, your brand names, and all that, right? So now the question is that when we go to cybersecurity jobs, normally what the cybersecurity professionals do, right? What exactly they do, what is there's a detailed methodology and the mechanisms and the theory behind it, that how should we protect the organizations from the digital attacks, what could be the ways, and there are a lot of theory on that. So essentially, what happened that when we talk about the cybersecurity, cybersecurity is not just about the technology. A lot of people think that cybersecurity is about the technology. Technology is just one piece, right? Technology is one piece. So we definitely, technology means that how to protect, like what type of mitigation, DDoS mitigation or antivirus, or like what technology I use to protect. But technology is as seen in this slide. Technology is just one piece. We cannot make an environment secure just by using the technology, unless we have the people who have the understanding how to secure and the processes to use them to secure themselves. So cybersecurity is a mix of people, process, and technology. Don't just think that technology can save you. No, no matter which technology, which best of the breed, top of the line technology you deploy, but still, if your people are making mistakes, they are not, they don't have the cybersecurity mindset. They start putting this, downloading this bad software. They download, the clicking on this spam emails. No matter what technology you deploy, it will eventually fail. You have to make sure people are educated. People are not clicking on these random emails showing them that they have $1 million lottery, and they just start clicking and downloading the softwares, and these softwares are eventually attacks, becomes the attackers heaven, right? So important thing is that it's not just the technology, it is the people and the processes. We have to make sure that people are cyber aware, they have the processes and to follow, and technology in the end is coming as a way to savior. But essentially, organization who are cyber savvy, they use all the three things to make sure the environment is secure. They constantly train their people on cybersecurity. They make sure that people who are doing the cybersecurity, they have the right processes in place, and they are using the good technologies to save them and protect them, right? So you can see that, right? So it's people to organization, people to understand their risk, right? And their action can impact the overall security of the organization. If you're clicking on a bad email, it's not just your damage, you can damage the entire organization. Maybe they will get access to your machine. From your machine, they will jump into another server, another database. They will get access to the critical data which they are not supposed to get access to, right? So people awareness is super cool, super important. Second thing is the process, right? Like the procedure to interact with the people and technology, right? How people should use the technology, and how guidance and policies, that who should do what, who should use what. Like, it's not that you should have a process to make sure that process and policies in place to have the people accessing the data, how they are using the data. It's not that marketing data is accessible to the engineering people, engineering data is accessible to the ordinary user, right? So you have to have some guidelines and processes to make sure that how your data is being used, how your technology is being used. And essentially, as I said, the important takeaway from this slide, keep in mind, cybersecurity is not just technology, it's about people, process, and technology. And this is the most important thing for any cyber professional to understand, right? And go through this video, right? This video will give you a little bit more on that one. So normally, as you said, right? So what normally we use to secure ourselves from the cyber attacks? Firewalls, definitely, as we discussed, are the most important thing. Is just the first. This is internet traffic coming from internet to my network. I have to make sure that there's a device sitting and listening to traffic and processing all the traffic. What is, and in firewall we do the policies, right? So we do policy here. We write what is allowed, what is not allowed. Whatever not allowed, firewall just drop it. Whatever allowed, it pass it on. So it's the first level defense, I would say, right? Especially a lot of people have started using VPNs now, or virtual private networks. And normally firewalls have the VPN capability also. So VPN is one of the functionality that firewall can provide, so people connect to the firewall as a VPN server, and they can gain access to internal resources. A lot of time in Pakistan, you know that, right? YouTube is blocked, or Twitter is blocked, and something is blocked. So people VPN to some device to get access to that, because once we VPN to that device, you become part of that network. So let's say you're sitting in Pakistan and you come to this firewall, and you VPN to this firewall. This firewall, let's say, sitting in Europe somewhere, so you become part of the Europe network now, right? So that's the reason you're able to access YouTube, Twitter, whatever is blocked here, because you're not part of this network, you are part of this network now. So security services, the first service is the firewall, which is the first level defense, I would say, for any organization. And then firewalls inspect the traffic, allows, denies based on the policies. So in firewall, this is a big job. A lot of people do this job where they do the firewall management, and they write the policies for the firewall. They allow, deny the firewall based on the type of access they need. I think this is a time for prayer break, Abdurim, or Umar. What do you say? Like, should we take a break? And what is the prayer time these days?
Yeah, it's 9:15.
Yeah, let's so take a break now. Let's come back as soon as possible. So meanwhile, we'll pause here,
Sure.
and we can take the questions. If anyone has any question, anything other than today's discussion, on the today's discussion, or anything other than that, we can just have a kind of a open discussion. If anyone has any questions on in general today's topic or previous topic or any other topic, feel free to ask now. Yes, Majid.
Uh, Sir, am I audible?
Yes, Majid. You are asking something?
Yeah. Am I audible? Is my
Yes, yes,
voice
yeah,
clear?
yeah, I can hear you. Yes.
Okay. Sir, my question is handling denial of service attack is the job of the organization or the cloud provider?
Normally, denial of service attack is an if you are talking about the cloud, right? So when you are working on the cloud, actually, what happened? Let me just go back to the slide deck. So what happened that in case of cloud, right? Let's say uh, you're taking a server from Amazon, AWS, or Google, or whatever, right? So it could be AWS, it could be Google, it could be Microsoft. So let's say you have a server from there, right? And you have a web server here, and cloud service provider CSP works in a similar way. They are connected to the internet, right? And so end user can come and access the services through their network. So what happened that essentially they also have this same concept actually. They have connecting to their ISP, right? And they are sometimes, most of the time, they have connection to multiple ISPs, right? So they have two, three, four ISPs, and they have big pipes actually, hundreds of gigs and all that. Same concept applies actually. So in this case, when you go for a cloud service provider, you have a cloud-based services, you have a web server or something sitting in the cloud and someone attacking it. This is the responsibility of your cloud service provider to mitigate the DDoS attack. If someone is generating a huge amount of traffic towards your server, so normally, if I understand correctly, this is DDoS is normally is comes by default with the cloud service provider. This is part of the responsibility of the cloud, but in some smaller cloud service provider, maybe they can sell it as an additional service. But essentially, what happened that because as an end user or the one who has bought a server or rent a server from the cloud, you really cannot do much on this one, right? This all dependent on the ISP and the internet pipe, and you are totally at the mercy of the ISP or the cloud service provider, because it's not that you can do anything to protect your server if someone is generating millions of the requests towards your server, right? So normally this is part of the considered as a part of the cloud service provider infrastructure, right? Whatever the infra they have, VMs or the containers they have given you, and this is falls into their responsibility matrix, right? So they are the ones, because what happens essentially that the web server having a public IP, and this public IP is getting attacked. So what happened that this is the responsibility of your cloud service provider, let's say AWS in this case, to make sure that they have DDoS protection, or the ISP they are taking service from, they have the DDoS protection to make sure that you're not getting DDoS attacks and bombarded and your server is going down because of that, right? But in some cases it could be a paid service, in some cases it could be a free service, right? It depends. I think it depends on, I think it could be a paid service, because sometimes cloud service providers can say that I'm paying for this service to my ISP, so I'll charge you back, right? So it all depends. But essentially ISPs sitting in the network, they charge for this service for sure, because I know that the companies I worked for and I worked for previously, we were charging for this service and we were developing this service, and this we are paying to our partners to develop this technology and all that, right? So we are paying a lot of money to the partners to protect from the DDoS. So definitely it could be a paid service too, but sometimes people can give it service for free, depend, and they may be charging, they will include this cost in the server cost that you have, right? Depending on the mechanism, but yes. So in this case it should be, if you're getting attacked, it should be your cloud service provider responsibility to fix it, right? You just have to maybe notify them that you are seeing this, your server becoming inaccessible, and they should be able to fix it. Majid, you are working as a developer for the cloud, or what? I think it's last time you mentioned.
No, sir. Web developers.
Sorry, I couldn't
I
hear
have
you.
web.
Web developer, okay. And
Yes,
you're
I've experienced 5 years of experience. I've been
okay.
developing websites now since I think first few 3 years or something.
So you do both front end and back end, both development means that,
Yes,
right? So back end,
yes,
for others, normally we see the web server, right? Web server,
yes.
but in the back end, there are a lot of servers connected to the web server. Normally is a database server connected. There is some application server in the backend connected. So as an end user, we see just the web page, right? But in the end, there's a lot of servers, and there's a huge engineering, I would say, or technology, the way servers process the information. There's a lot of development happening. There's a lot of database administrators. So a lot of jobs, a lot of people, they are doing this DB level job. They just set up the database. Some people will just work on the application developers, and some people will work on the front portal only, right? So this is all called backend. This is all backend. What you see is the front end, right? Here end user is seeing the front end, but a lot of interesting technologies and development is happening on the back end also. So Majid, you are on front, back, both, or what is your domain that you mostly work on?
So I know both, but depending on the requirement, I work like, for example, React JS framework is there, right? That or Python for backend.
Okay.
Initially, I was working with PHP, but now Python or Node.js.
So, Majid, it is interesting because I think some of the people in this call today, they are definitely are working on coding and development and web development and OpenStack development and so on and so forth. So, tell us about more what you are using mostly, what tools, and let's say you mentioned Python, and what you're using mostly on front end, and what are the common technologies that's in the industry today for the front end, and mostly which are the developers using, and what are the technologies people are using mostly on the back end, or common technologies, I would say, right?
Okay. For front end, sir, we use React.js with Material UI for creating components, and there are other things as well. But mostly, I work with React.js, Material UI, and for
Can you type
backend,
in the
Python.
type in the text window, so it will be, when, because sometimes voice is not
Okay,
clear, right? You can type front
okay,
end and back end in the chat window. So I will type it for the sake of others who probably will not in
sure,
the
sure.
class. They can review the recording later on, right?
Okay.
Because the whole idea is that share what you know with others, because a lot of people will definitely gain inside that. Let's say what is common in the industry right now, let's focus on those learnings, right? Let's say someone is working on Python is good for them, but what else they can learn, right? Thanks, Majid. Okay, okay, let's start. So cybersecurity is a people, process, and technology. Let's get back to the concepts. And second important thing is the services, right? So normally the security services that as a cyber professional work on mostly is that they work on a lot of firewalls to make sure that they understand the requirement from an organization perspective, what is allowed, what is denied, so you can stop it right at the firewall. Firewall is the first line of defense, right, within your organization. And so whatever the bad traffic or undesired traffic, you can say, you can drop it right up there. It will not go inside your network. So firewall expertise are very, very precious expertise. You need every vendor, let's say Cisco, Palo Alto, Fortinet, Sophos. There are a lot of vendors. They're good vendors. I would say all of them are doing their part, and they everyone have their own way of configuring the thing. So that's where you learn. Let's say how to configure a Cisco firewall, how to configure a Palo Alto firewall, how to configure a Fortinet firewall, and it's not very difficult. I would say as long as you know the technology, you understand what is the IP addresses, what is the port numbers, what are the protocols, which application is using what are the categories of the application. And a lot of people are coming with simple GUI now, right? Graphical user interface. You can just go and configure the policies, but important thing is to know what you want to do, what you want to achieve, what is the end result you want to achieve. You have to understand from the user perspective, what are their requirements and what are the business goals and what trying to save, protect. Based on that, you come up with the security policies to achieve those business goals. Second thing is endpoint security. Endpoint security is, think of endpoint security just like antivirus on your device, right? A laptop, desktop, whatever. So essentially, in old days, we used to call it antivirus. Now it's much more than antivirus. Is endpoint security, we call it EDR solutions. And sorry, and this EDR solution is just, antivirus is just one part of that. They do a lot of monitoring and checks and make sure that no malicious activity is happening, no one is getting control of your laptops or PCs or machines. And so they are much more smarter, right? So they are much more than the antivirus now, right? Because there used to be old days where people just used to install the antivirus files and antivirus signatures or match or allow denied access. Now attackers are using a lot of sophisticated techniques. So only antivirus is not enough. So you need a full suite of technology. So endpoint normally is that, bring that suite of technology from the endpoint perspective. It keeps an eye on everything happening on the endpoint, just to make sure that if someone is misusing your memory, someone is trying to gain access to certain memory portions, they are not allowed to gain access. Someone is trying to run a process which is not required normally. So they try to stop all of that. Antivirus used to just check few signatures and based on that it allowed deny, right? So endpoint security is another field where a lot of security professionals work. And this endpoint security, to tell you the fact, it requires a lot of in-depth knowledge about the operating system, the way operating system works, right? So that's the reason, as I said, like in order to become a good cybersecurity professional, you have to have the knowledge of, let's say, Python. Sorry, I misspelled. You have to have a good knowledge about Python. This will help you a lot. And at the same time, you have to have a knowledge, very good knowledge about operating system, how the operating system works. Because at the end of the day, when you're troubleshooting your user, need to understand how the Windows works, what are the processes Windows normally run, how the memory is being accessed on the Windows platform, what are the registry entries, what are the DLL files. So if you know all of that, if you're good in operating system, that will help you make your job of cybersecurity professional very easy, because you can immediately catch up the attacks happening, where it's which memory portion is trying to access, and you can block it, right? So knowledge of operating system is super critical, I would say, for the cybersecurity, and not just cybersecurity, I would say for any profession, because end of the day, as a coder or developer, you have to develop your application for certain operating system, right? So gain knowledge of operating system is essential. Having knowledge about Python is essential, and especially from the endpoint security perspective, this endpoint security, it all dependent on what operating system users are running, and how hackers are trying to get access to those operating system, and maybe some vulnerabilities or open ports and so on this operating system, right? So gain a lot of good knowledge about operating system, and so you will, once you have a solid knowledge on operating system, then understanding the endpoint security, how the endpoint is behaving, and how the security tools are used to protect your endpoints, it will be far easier. And again, it's not a rocket science. Vendors are developing this endpoint technologies, endpoint EDR technologies, endpoint detection and response technologies. All you need to know, you need to understand what you are trying to save, and how hackers might be misusing your environment, and you just use your common sense to link these technologies and these attack techniques, and just to protect your environment, right? In the end, everything comes and boils down to the common sense that you have to apply in any scenario in the life. But this knowledge and background, this operating system knowledge, let's say this Python knowledge or this EDR technology knowledge helps you to achieve your desired results very quickly. Security, again, Majid was mentioning about cloud. Cloud is the one where we rent the servers instead of building our own server. We go to the cloud, we take a web server, or we make a server. We take 1, 2, 10, 20, whatever the number of servers we need, hundreds of the server. In big environment, there are thousands of servers. They rent it from the cloud. Some servers are front facing servers, some are back end facing server. But end of the day, if you are a developer, you would care about your application, right? And front end or back end, whatever you are working. But essentially, no matter what you do, right, you have to make sure that it is secure, because what happened that in the cloud, this is the way it is, right? You have internet connectivity on your cloud service provider. I call it CSP normally, your Amazon Web or whatever, and that's where you're taking all these servers, right? And your end user are sitting here. This is where your user sitting here, and they're trying to access a server. So you have to make sure that your server that you are taking from the cloud is secure, right? And what you normally have, a lot of security technologies are available to protect the cloud infrastructure, because cloud infrastructure, if you think of it, right, is sitting somewhere on the internet, and anything that connected to the internet has an inherent vulnerability, an inherent, I would say, uh, risk of getting exposed to the hackers, right? So anything on the cloud definitely comes with a default risk that needs to be mitigated, because internet by default or by definition is internet is by definition insecure. So anything connected to the internet inherently insecure unless you do some security enforcement, right? So internet is inherently insecure. Keep that in the mind. Anything any connected to internet is insecure. So that's the reason a lot of technology is available. Cloud service provider provide a lot of native technologies to secure it. Sometimes people buy third-party technologies to secure it. Let's say the key management is the big thing on the cloud, like how you do the key management, right? How you're doing the encryption, how you classifying your data, how you logging your things. So anything goes wrong, you can check the logs and see where it went wrong. User behavior, as I said, right? User behavior is important, that user are accessing resources in a certain way, but someday someone bad is happening. Someone, let's say, is accessing the user number. Let's say myself, Haris, is logging in every day from Canada, but one day I log in from Pakistan, right? So that should trigger an alert that why this user, which used to log in 365 days from Canada, one day is logging in from Karachi. Although it could be legitimate, I maybe went on vacation, but it should generate an alert. That's because same thing happened, right? Let's say a user is sitting in Pakistan, is accessing the resources. One day, if that same user try to access the resources from the Russia, it might be an attack. Someone is maybe taking access to your identification and trying to access the critical resources and impersonating like you, right? So this user behavior important, who's approving these access levels, and how, what type of access controls are there, how user getting authenticated. So a lot of security enforcement is available for the cloud, and a lot of security provider actually providing those services to make sure that your cloud servers and cloud workloads are safe. So this is again whole new area for the jobs, right? A lot of people are expert in cloud security. A lot of people are expert in the network security, which is the firewalls. A lot of people are expert in the endpoint security. So these all are the potential job avenues, right? To develop your skills and expertise around these areas will get you a job for sure. Application security, that normally goes to, let's say, on whoever is developing the application, and making sure that application is secure, because end user are accessing over the internet to your application, right? To make sure that the repositories that you have, the code that you are using, and make sure that application that you have developed doesn't have any vulnerability, doesn't have any OS level vulnerability, doesn't have any application level vulnerability, doesn't have any code level vulnerabilities. So this is, again, there are a lot of technologies available, as normally people use the penetration testing before going live. So before going live, people use uh, pen testing, just to make sure that, especially in the banking environment, is very common. Before launching a banking application, they do a lot of penetration testing, quality testing, just make sure that attackers are not able to gain access to any vulnerabilities which are in the application. Data security, again, let's say you have a credit card data sitting in a file, right? That's sitting in a database. So data security is again important. So normally whoever is managing the infrastructures, network and security guys, normally is the security guys, or the CIO is the one who is responsible to make sure that Banks, let's say you have a user credit card data, you have your health data, you have some other data, which is very critical data, which may have some privacy data, right? Which may have some private information. So that data is secure, and normally the best way people do security on the data is normally encryption of the data. This is important, and also the thing is the technology is another technology used is called DLP, data loss prevention, or sometimes people call it data leak prevention. And this DLP technology is important that let's say you're not allowed to share your social insurance numbers or your health card numbers, right? Or let's say credit card numbers sometime within your corporate environment, right? And someone do it by mistake, then there should be some mechanism within the technology or within your organization to stop this loss of your data, right? Which is credit card number or your health card number or whatever. So sometimes there are tools available to avoid leakage of such information, just to make sure that data is secure. So data security again, is very uh, big topic in the cybersecurity, just to make sure that only authorized users have access to the data, and when data is not in use, the data is destructed, right? In a way that it cannot be reused or misused. Data is not altered. So data security itself is a big topic in today's world. And again, there are a lot of jobs there, just to make sure you understand the technologies available to secure the data, the DLP technologies, the encryption technologies, especially the way encryption is done, the way encryption achieves the security, what level of encryption you are using. And because encryption can be broken in some cases if it is weak encryption, so you have to make sure that uh, you are using the right encryption, because encryption, if you're using the too complex encryption, is good, but is it takes the resources, it takes the CPU and all that, right? So you have to come up with a balance, because you end up spending maybe too much money out of your budget and all that. So you have to have a balance to have the data security, that what is the level of risk you can accept, and rest you can mitigate, right? Okay, and this is another tool very commonly used now. It's kind of been there for 10-15 years. SIM, they call it normally SIM, Security Information and Event Management. It's like uh, it takes the logs from the devices and it analyze and it do the detection, right? It actually takes the logs and do the detection, and sometimes it can also do the response. Means that if someone is, let's say, same example as I said, right? A user sitting in Canada and accessing the servers or services every single day from Canada, and one day he logs in from Russia. So this normally SIM is the tool which tells you that, oh no, this is not right. This user behavior is not correct today. He used to access, let's say, certain files. Now he's today is accessing some other file. So this user behavior or some other behavior, and analyzing the log or data that we have collected from the devices, and based on that doing some security alerting and responding to those alerts. This comes with a tool called SIM. These days, this tool SIM is getting sometime. I would say that SIM is the old tool being used for many years. Now is evolving more of like an XDR tool, extended detection and response. It does a similar thing. Actually, it takes the XDR tool is similar in a sense that it takes the information from a lot of network devices and it do the analysis. And based on analysis, it can say you that, okay, you should not do this thing. This user behavior is not good today. This is doable. This should not be allowed. And this is more of an XDR is more of a comprehensive term, and this is the way industry is leaning towards. For you guys who's trying to make a career in cybersecurity, you will definitely have to learn a lot about XDR, extended detection and response. So this is similar to SIM, but more advanced. I would say it's advanced SIM. I would say in very plain, simple English word. Okay, so again, this I will not go into detail. This is way too deep for this discussion. But identity management is like, in simple words, in a plain words, in a very high level view, I would say user ID password, right? Like we all have user ID password for our Gmails, office accounts, our corporate accounts, our university account. We always have a user ID and password, right? So this and that user ID actually is our identification within the network. Let's say If I'm using Gmail right now, my Gmail ID is linked to my Google account, right? And Google account is my identity. But sometimes identity is not just limited to the username and password. Username and password definitely is one thing that identity does, right? Authentication is authenticate you and validates you whether you are the user you allowed to access. Let's say you're logging to your Gmail, but sometimes it's not just limited to that, right? So in organization, the way it works, you have to have the user ID and password, but after that, there is a level of authorization, right? In good organization, this is the way it is. You have authenticated, okay, this is, let's say if an engineering user is authenticated, yes, authenticated, but if he's trying to access the financial data, finance account data, then it will not be allowed, because you are not authorized. You are a, let's say, marketing guy trying to access, let's say, engineering data, you are not authorized. So in the organization, people deploy the technologies to make sure that user have the right authorization. You are accessing only what you are allowed to access. You cannot just randomly go and start getting access to others information and data, right? So this is authentication is one thing which we all are familiar with: username, password, or our tokens, or authentication tokens, or SMS tokens, or whatever. Authorization mostly is on organization levels, and user management again on the organization level. Let's say if user is joining or resigning, I have to create an account, I have to delete an account, and then authorizing account. User management is normally is an again IT job. Sometimes security people do, sometimes network people do, sometimes other people do, but it's an IT job, and it's kind of falls into security that we have to make sure that user have right access. It doesn't have the more access than it needs, right? And this is very critical to make sure that every user has the access they need to do their job, but they don't have more than what they need to do, because if they have more, they can damage, they can get access to some data which they are not allowed to access, they can delete the files, they can do something wrong. And again, central repository of the user is and that normally comes through a technology called Active Directory. That's where normally people have Active Directory, or I call it IDP. So identity management is a whole domain for the cybersecurity. Again, it's a lot of people do job. They are expert in identity management, authorization tools, access management, and the way Active Directory works, how to categorize the user, how to make the policies. Sometimes you have complex requirement. Let's say you have a contractor coming and working for 2 hours, so you have to give them access for 2 hours only. It's not that you create account and you forget account, and even this contractor has finished the job, his work is over, still he's having access to the resources. So a lot of interesting things and scenarios come in the identity and access management. Is the area itself is called IAM, Identity and Access Management, and it's a very flourishing area, I would say, from cybersecurity perspective. Cybersecurity is a whole lot domain. It's lot of technologies are inside, lot of expertise people can build. So that's the reason there is a huge career path there. There are a lot of fields you can focus on. You can build expertise, and this will happen once you go to organization. Then you will realize that the area that you can focus and build expertise on, right? I will not go more detail. Encryption is very simple word. Is your plain text, whatever you type, it encrypt into a garbage. It looks like a garbage to anyone else. It's a ciphertext, and this is the encryption technology does, right? So is the cryptography or encryption is the taking the plain text and converting into some cipher. Only thing is that authorized people who know how to decrypt, they will be able to decrypt. Rest of them, if someone else is sitting in the middle trying to sniff, trying to gain access to my information, they try to steal this packet, they will not see anything. They will just see this garbage thing, right? Which is meaningless. Let's say I'm saying hello, which is the English word, which makes a sense to someone, but a hacker will see, they will not find any meaningful information. So this is the concept of the encryption, that taking a plain text information, making a cipher, and when a receiver receive it, decode it to the again to back to the plain text. So cipher is converted back to the plain text. In Pakistan, cipher word is getting very notorious. But that's the way. There's a whole concept. Even that cipher that they are talking about, the government is the same thing. When the government exchange information, the critical information, they send a cipher or encoded information, which only the, let's say, foreign office can decode, and foreign office knows that how to decode and how to extract the meaningful information from that coded message that one government has sent to another. And this is a simple thing. I will not go into detail. Again, this is encryption has two ways of encrypting the data. One is symmetric, one is asymmetric. Symmetric, plain words, use the same uh, key or same way to encode and decode the message. The key is the same. You can see here, right? The same key is used to encode and decode. But again, this is good for a smaller environment. But again, this is, you can imagine, less secure, because if keys is somehow, like, gain access by hackers, one key gain access, they can decode, right? Because same access key is used on both sides. But in the asymmetric key, there's a different key to encode, different key to decode. They call it a concept of the public and private key. Since they are two separate keys, so even someone gain access to one key, they cannot get access to data until they have a combination of both. So someone needs access to both to decode the data. So asymmetric is more secure for sure, but definitely asymmetric requires more effort to do this, because you have to have a public key and private key and both keys, and someone has somehow they have to work in a way that whoever is decoding the information, they have access to both. So the encryption is very important tool for the cybersecurity, I would say. And encryption, it helps to secure the information. A lot of web pages, especially if you see that HTTPS, the S in the end is called secure HTTP, right? This HTTPS is secure. So let's say right now our information on this Google Meet is actually using HTTPS. So it's kind of encoded, and encoding normally use the terminology called TLS technology, transparent transport layer security. This is the encryption mechanism is used. Old days we used to use a thing called SSL, but now we use transport layer layer security. And this is right now, if someone is trying to hack and try to steal our packets, let's say in between, it's encrypted, so they will not see anything. They will not be able to decode it unless they have access to the public and private keys, right? So I will quickly, this is just this slide giving that normally what happened that in organization, there is a mechanism called cybersecurity governance, right? Like how they run the entire cybersecurity program to make sure that the network is secure, their data is secure, they have the encryption, they have the like the DDoS, whatever, right? So there's a governance process, like the normally the your CIO or your company's corporate information officer is someone who runs this governance, or the team under him. They want to make sure that what data is important, what data is less critical, which data has to make sure that we have the security enforced, encryption enforced, we have the some compliance, what security standard we have to follow, what who will do what. So this comes into the governance, right? Running your overall cybersecurity program is called the cybersecurity management or cybersecurity governance. Normally that falls into the kind of teams that you will have to manage your cybersecurity. Means that there will be certain people who will be doing cybersecurity infrastructure, right? So they will be doing the cybersecurity infrastructure. Means that your firewalls, your XDR solution, your EDR solution, whatever that you are using, right? Overall infrastructure, there is a team doing that. And some people are doing this pen testing, red teams, blue teams. They are trying to mitigate the attacks, they're trying to simulate the attacks and making sure that if someone trying to attack, what will happen, right? So prevention, they are doing prevention, right? So red teaming and blue teaming activities and vulnerability management, they're making sure that if softwares or the operating system that we have, they are secure. So there's a team managing overall infrastructure. There's a team constantly doing tests on your application. There's a team on the compliance level. Right? A lot of big banks, especially, or the large organization, they want to make sure that we follow the standard cybersecurity. They're a big organization in the world. Let's say NIST is North American, and GDPR is the European one. HIPAA, if I understand, is Canadian, and PCI DSS is for credit card information. FedRAMP is the federal organization in the US. So these are the very well-known standard organization. They have built and developed very strong guidelines, right? And the processes and guidelines that you should follow. If you are following these standards, if an organization is following and complying to these standards, means that they are secure. So these standards, most of the organization in North America follow NIST actually. People in Europe mostly follow GDPR, and and credit card companies follow this PCI DSS standard. So once you follow certain standard, means that you are abiding by their rules and guidelines, and you are secure by default. If you follow any of these standard and you got the accreditation from these organizations, then your organization is trusted. You get more business because they know that you are secure. So a lot of jobs around compliance also. A lot of people do compliance check for the organization, and they, based on that, they say that you have some gaps you need to fill in, and you need to make sure that you achieve your certification before going to the public. So this helps, compliance helps organization achieving the trust, and there are a lot of jobs around that, right? A lot of people do the security operations, mean day-to-day monitoring of the alerts. They do monitoring of the alerts, and they see any alarm, they fix it. And that's where the SOC team use the tool I mentioned about XDR and SIM and all that, right? They use these tools. So they are the one who are the one monitoring the services on a daily basis. So these are the different roles happens on the cybersecurity, and overall the cybersecurity governance is happening through a CIO who's leading a different teams, and these teams, infrastructure team, penetration team, compliance team, or security operation, they all work under the cybersecurity governance that an organization do. Very quickly, organizations sometimes have the concept of the red team, blue team, purple team. Red team is the team who they hired someone to attack on their infrastructure just to make sure that they are secure or not. Let's say application before going live, they want to have an attack just to make sure that if a code is secure, application is secure, infrastructure is secure. So red team is trying to attack, and mostly is a controlled environment. These are team paid for that. And blue team is the defenders. They are the one who trying to defend, right? So red team, blue team exercise normally tells us that how secure organization is, and organization do this red teaming, blue teaming exercise just to make sure that they are ready for attacks and their infrastructure is ready, and they don't have any open vulnerabilities and open attack, open things that they can some hackers can misuse, right? Purple team is kind of an intermediary that allows communication between the red team and blue team. But red teams, you can imagine, is more of offensive team which do the attacks, and blue team is mostly a defensive team, and purple team is kind of coordinating in between them. As I said, governance, risk and compliance is again, it's like a framework that people follows, this GDPR and all that, HIPAA, and this is like a, if you follow any of this framework, you then your organization is secure, right? So a lot of people, but following their guidelines and principles, any of the principles of the compliance framework that you use, it requires a lot of effort and money to make sure that you are compliant. That's the reason once you are compliant to any framework, NIST, GDPR, PCI, then you are trusted. Your customer will trust you that you are secure. A lot of large organization, or especially middle-sized organization, also go for compliance, and a lot of jobs come with the compliance, right? This is just a high-level view from the security operation perspective. They do the monitoring, alerting, they do the recovery. If someone getting attacked, the security operations team, who is the one who normally work on this attack to mitigate it, to recover it, and they do 24/7 monitoring. That's the most important job for the security operations center, is to proactive monitoring. They constantly monitor and they get alerts. How do they monitor? They have the tools like, as I said, they have a tool like XDR or SIM or this tool. They see the alarms coming on that tools, and they do the monitoring. If something going wrong, then they try to mitigate. This is the uh, part they try to do, right? That they respond to the incident. They make sure that environment is has the compliance, and they make sure that their assets are protected, right? So this is all the jobs of the SOC, and they are the most, I would say, the most jobs are produced in the SOC. Most of the jobs, security analyst jobs, are in the SOC, and this is a very good start for anyone to start the job as a SOC analyst or SOC administrator, and after that move on to different roles in cybersecurity. But SOC is give you the most visibility, because that's where you're seeing the real alerts or alarms or attacks are happening, and you're trying to fix those alerts, right? So last time we went through that. These are the few skills that you should work on if you want to make a career in cybersecurity. These are skills are super essential, and these skills, in my view, they are not just for cybersecurity. They will help you in your other career path also. Especially, you have to make sure that you gain a knowledge on Python. No matter what career you are on, you are a network administrator, you are a cybersecurity administrator, you are an AI, whatever you do, you having knowledge to Python is super critical. Especially, second thing is the every technology, whether you are using XDR technology, firewall technology, SIM technology, what technology you are using, every technology vendor is start using the artificial intelligence, Gen AI, ML. These are the words, buzzwords you will listen a lot. So every technology is coming up with certain tools which are using AI, artificial intelligence. So you make sure that in your domain or your area, you start using AI based technologies and getting more and more familiar with AI based technologies. Third thing is operating system will go, I think in next classes will go more. As I said, operating system knowledge is important, not just for cybersecurity, it's good for others too. And it's essential knowledge, I would say, especially the Windows, Linux, and are very important to know. Basic of computer networking always help you. As I said, like in cybersecurity, a lot of time we are talking about the attack is generated from certain IPs and going towards an IP, and there are certain ports their application use. So networking basic knowledge, because that's where you know that what is IP address, what is MAC address, what is the port number. So this basic computer networking also help you in the cybersecurity for sure, right? And last but not the least, the most important thing is to constantly learning about the attack techniques and tactics and which the hackers are using, right? So TTP is a word they normally use, the TTPs, tactics, techniques, and procedure. This is what the hackers constantly evolving themselves with. They're coming with new techniques and tactics and new ways, let's say new spams and new emails and SMS techniques to send you and lure you, and they sometimes make the message so attractive and it sounds like it is for me, right? I should, yeah, I'm expecting a delivery from FedEx or TCS or Amazon, and I'm getting a message right at that time. So I think that is for me, but it's not for you. It's actually an attack technique. So you have to constantly learn about the new TTPs as a cybersecurity profession, and this is not rocket science. Again, I would say that the vendors and the technology vendors are developing technologies, they are developing certifications to make sure that you are updated with the new techniques that hackers are using. So these are the some of the technologies, I would say, this as a professional, to adopt a profession in cybersecurity, or I would say in most of the fields in IT, you should know a Python now, you should know AI now, you should know operating system now. Having knowledge about computer networking is also a very good fit. I would say it helps you in everything. So work on these skills. These are very important skills for the future. I would say in next 10-15 years, I would say, I would for 10 to 20 years, these skills will be very valuable. So try to build your expertise. Right now, whatever we are studying here, it's just the basics, right? So you have to make sure that you keep learning next few years to build your more advanced knowledge, and you become expert in any of these fields or some of these fields, right? Because if someone is giving you work and paying you a big salary, then you have something which not everyone else has in the world, right? That's where the money comes, right? So you have to make yourself and bring your knowledge from zero to hero level, I would say, to advanced level. Then you will start getting the opportunities, and a lot of good money start coming in once you are expert. No one wants to pay for to hire you and teach you just to learn, right? They want to you to deliver certain things, and that's where the money comes. The mediocre gets mediocre salaries, the top guys gets top salaries because they are doing something which not everyone else is doing, right? So you have to make sure that you keep working in your goals and direction, and you make yourself an expert. Don't expect that in one day you will become expert. It's a path. You have to constantly learn it. New technologies will come, and you have to constantly keep adopting to those technologies and keep learning, right? So if you want to make a career in cybersecurity, these are the recommended path that I have sh- shared with many times with many different people and groups. There are a lot of free sources, free courses, free technology available on the internet. Eureka courses on the YouTube. Fortinet is a very big vendor in cybersecurity, well-respected vendor. They have free certifications, actually FCF and FCA. Fortinet certified fundamentals, Fortinet certified associate. They're two certifications which are totally free and well respected in my view. Go for them. Uh, Code Academy has certain cybersecurity knowledge, and Google has done a wonderful job. They have these YouTube videos, which is free to available to everyone. 18 videos, I think 1 hour or so, around 20 to 25 hours video. Very good videos, and I have prepared some slide deck and trainings. You can go through that. Cisco Academy has courses, so there are tons of courses which you can get and gain your knowledge without paying anyone, right? Eventually, once you are done, you can get a certification. Google certification is available from Coursera, ISC2 is free these days. Again, it's a $300 exam. ISC2 certification is free these days. You can do it. I can help you if you want to know how to register and do the exam. And Google course, everyone can do, in my view, right? So there is no excuse. If you want to make a path, there are free resources available. And Coursera, again, I said financial aid is available. Google certification is well worthwhile. You can do this Google course on YouTube first. Once you're ready, you can get the Coursera certification. And last week, I think we had a Frank came to our class, and Frank is again a new guy. He has no much, not too much cybersecurity background. He's making a path in cybersecurity. So he has done. I actually went through some mentorship course with him. So I was his mentor. So I asked him, and he done through this course. He went through actually this slide deck, and he went through Google course, and he achieved this certification after those courses, and he achieved ISC2. Actually, he just achieved 2 days ago also. So this is what it is, right? So if you want to make a career, this is a good start to start with. And this, all this on this deck, you see, this will, in my view, will make you not just a beginner. It will give you the knowledge that is required. I would say after doing all of that, you will become an intermediate knowledge holder in the cyber security, at least, right? You are not, if you go through all of that, you will have enough knowledge to make a good career in cybersecurity. So make sure you want to make a career, go through all of that. And important thing is education, knowledge. You have to keep learning, keep learning, keep learning. That's the only way to grow in any industry. It is not just IT. Education and keep gaining more and more knowledge is the only way to, or only path to success, I would say, right? So, and good thing in today's world is that you don't always need a degree to make a good career. As long as you are good in what you do, then you will be successful in your path, right? So keep educating yourself with new technologies, new things, and keep growing, right? Keep learning, keep growing. And I think in the last course that we have done, I constantly have a quote that I was referring always, that you have to have a growth mindset. You have to make your train your brain in a way that it's a growth mindset. It's always growing, it's always gaining more knowledge. It's not stopping. What happened in industry, especially in IT industry, a lot of time people get in their comfort zone. The comfort zone is a very bad place to be in, right? Because you just get used to of you do every day. Like in our old days, our parents used to do a government job. They used to go to a job. They used to do the same thing every day for the 30 years. They used to do the same thing, and they were in their very much comfort zone. But today's environment, if you are in comfort zone, then you are actually very, very well behind others, right? So industry is changing, and those who are in coding and open stack development, and they are seeing that everything every day, so much is changing every day, new things are coming. So only way to survive and thrill in this world is to educate yourself every day, keep learning, and that's the only path to success. And if you are committed, motivated, you're paying your efforts, you are becoming expert in your field, no one can stop you growing, right? So this is my advice, and this is my, I would say, end of the lecture today. That once This is the whole certification I was mentioning, right? So this is on the YouTube. You can see that this is a very good certification, and Google has put a lot of efforts, and just to make sure it has covers a lot of domains. And you see that it will cover a lot of things that you know, a lot of things that you don't know, a lot of things that we touch base: Linux, Windows, penetration testing, red teaming, and so in my view, the organization like Google are well respected. They're doing a lot of efforts to make sure that right now there's a gap in industry for the skilled professionals in IT, cybersecurity, coding development. So they are doing their best to put a lot of knowledge in the industry, and they want to make sure that there are people who can gain this knowledge and come to the industry. But only thing is that this industry is not for those who want to in their comfort zone. Is only for those who want to constantly learn and grow and make a good, respectful living out of their career, right? So a lot of information for free, I'm saying, right? Do you see that, right? This is a huge, tons of great resource in my view, even for knowledge. And this course will give you the knowledge, and you can gain certification from the Coursera to show off in your CV and LinkedIn and so on, right? So there is no excuse, in my view, these days. There is no excuse if someone wants to learn and grow in their career and find a career. There is a way. Okay, definitely it takes some time to achieve or gain the first job. It takes some struggle to make a first step and at least get and find a first job. But at least you can gain the knowledge and make yourself ready when the opportunity comes. Opportunities come and go, right? If you keep working and growing your knowledge, you are expert in your field, eventually you'll find a opportunity. So there is no chance that you will not find opportunity. They will find opportunity. It's just a matter of time. So I will stop here. Any questions, any comments? Not just the question, if you have anyone has any comments, so feel free to ask now. And one important note, I think the next week is gonna be the Eid weekend, right? So Eid will be probably in some places in Sunday, some places have Monday. uh, I was thinking that maybe we can keep an informal class. I don't know, because some people mentioned that they will be busy with the arrangements of the Qurbani and the Eid and all that, right? So maybe we can keep 1 hour short class just to discuss, if someone has any career kind of thing, just keep it probably an open discussion from the career counseling perspective. If someone have any comments and something, or because tell me, let me know what your views are if you want to touch base on a specific topic. I think AI topic I was thinking, but AI topic will not be a good fit because AI is an important topic and I want to keep it after Eid when more audience is available, right? I want everyone to take advantage of that session. So let me know what you think next week. Should we have a class? Should we skip the class? Should we keep an informal class just for open discussions? So I'm open for ideas for sure. Yeah, so I'll pause here.
I think we should go for an informal class because we have a lot of confusions about career paths and roadmaps and a lot of questions. Like as a student and as a freelancer, I have very different works to do. Obviously, maintaining the studies and lots of things. So I think the informal class would be a good option.
No, sounds good. No problem. Inshallah, we'll do it that way. Because as I said, I keep encouraging every one of you just to work hard and study hard. And good thing in IT is that you don't have to go to a formal university, right, to make a career. And even if you go into university, is good. I mean, the university education always help to grow in the career. But at the end of the day, it's not necessary. It's not essential, right? Even I have seen people in medical, right? People are in medical field and they switch to IT and they make a good career out of it, right? Because all whoever can pay effort, they can make a career, right? Is you don't have to have some special background. In order to become a doctor, you have to have some background, but here it's different, right? So even I've seen people are who went through MBBS and they completed their medical degree, and even after that they switched to IT. Even one of my actually nephew, my cousin's son, he was in medical. He was like a pharmacy. He was a researcher actually. He was researching on a lot of medicines and a lot of good academic background actually from the medical perspective. He was in medicine research and all that, and he worked there for 7 8 years, and now he switched to IT because apparently he said it's not money is not good there. Although it's in my view, he was very academic, very good knowledge, but end of the day, right? Everyone wants to make a good career out of the profession. They want to make a reasonable amount of money and all that. So this is it, right? So he was 8 years researching the medicals and diseases and medicines, and all of a sudden he took some courses and he came to IT, right? He became a quality assurance QA for some codes or something like that. So I don't know. So this is what it is, right? So the sky is the limit in my view, right? In IT.
After observing lots of things and taking classes, I've come to the conclusion that we also uh, have to do jobs according to this because in the last class, maybe properly, uh, I've heard that we should do a IT help desk job in the starting. So
Yes.
this,
Yeah. I mean that's a great start to tell you the truth. If you ask me, IT support desk, IT help desk is a good start. it gives you a lot of visibility, right? I mean, we can discuss more probably next week, but this is what it is. If you can find an opportunity, even fixing PCs, right? That's how a lot of IT help desk started, right? People have good knowledge about how to fix the PCs. Sound card is not working, display is not working, mouse is not working. They start fixing those small problems. They seem small, but nothing is small. So I mean, yeah, that's a good start for sure. And like now it's not that bad. Before it was hard to find a job. Now if you are skilled, a lot of people will find job offshore, right? Somewhere outside, somewhere remote. Maybe it's not paid good in the beginning, but eventually, yeah, the opportunities are will be there for sure. As long as you are skilled, you are preparing yourself with your knowledge set is updated, and you are good at what you do, and you are hardworking. Inshallah, eventually you will find a way. This is the whole idea. You will find a way, but make sure that you have that right set of knowledge, right? No one wants to hire a beginner. Normally people want to hire with someone with intermediate level knowledge, at least, so they can train them to the advanced level knowledge, right? Don't expect companies to hire you with zero knowledge and give you good salaries. No, that's not going to happen, right? You have to show them something, then on top of that they will hire you and train you, right? So
Okay,
yeah, next week
that's
you
why I
can
was
go through career counseling thing. I
okay.
have few slide actually, which we have shared with some other sessions. Actually, I've shared with some people. So yeah, we can go through that for sure. So I'll be connected for a while. If anyone has any question, otherwise we'll wrap it up. Thank you.
Thank you, sir.
Could you go over the SIM over again?
SIM, okay.
Yes.
So SIM basically is a tool, security, information, and event management. So security, information, event management. What essentially it does actually, the way it works in a very simple way, right? In what happened in any organization, in any company, what company has a lot of servers. They have applications, they have users like you and me sitting on our PCs and laptops and working. So what happened that what the way SIM works is says give me all the logs, whatever the logs that you have, like means that any alerts, anything going wrong, you send me. SIM takes everyone's logs, and then it has some special modules built in that. These are the analytics modules, right? These are the special modules, special technology. So these are the special analytics modules built in that, and it does the analysis of this log. And and it has some use cases. Use cases means that you tell him sim what you are looking for out of this data. So you have analytics tool, and you build a use case. Let's say you build a use case saying that check all the logs and tell me if someone is logging in from outside my country. Let's say your country is Canada, right? Let's say if any user is logging in and using the services from outside Canada, generate an alert. So it will generate an alarm. Okay. So this is what SIM does. SIM takes a lot of data. It do the analysis. Based on analysis, is generate an alert, and based on the alert, okay, the guy sitting in the SOC, Security Operations Center, they can see this alert and they can work on this alert. Okay, if this is legit, let's say if the user is logged into China, Canada for every day, one day logs in from Pakistan, then it's an alert. Okay, and sometimes it says, oh yeah, this user is on vacation, is traveling to Pakistan. It's a legitimate alert. I can ignore it. But let's say if that's not the legitimate, let's say this user was not supposed to log in from Pakistan, but he did, then he can generate an alert and it work on alert. Maybe he can block access. He can block this user access to the network because it can be harmful. Maybe it's not from a place which is not supposed to log in from, right? I'm just giving an example to Pakistan, Russia, China, whatever. But sometimes it's just a thing that as per policy, you are not supposed to log in from other than your home country. So as a SOC analyst, you will see this alert, you will investigate it, and you will block it. So SIM is a tool which collects the logs, we do the analytics and use cases, and it generates the alerts that SOC can look and fix the problems on.
so it is
So could you
necessary
explain
to.
again the socket? Sorry.
Sorry, go by one by
Sorry,
one.
sorry, sorry. You go first.
Omar, go.
Thank you. Could you explain what SOC is?
SOC is a security operations center. This is the thing that you see in the movies, right? In the movies, what you see, that you see a lot of big screens, right? A lot of time in the movies, what you see, that lot of big screens, and these big screens actually are the one which are people are watching, monitoring. That's where the alarm comes. It's called security operations center. So what the SOC is, Security Operations Center. This is the team which is monitoring the alerts all the time, and they are seeing that what is going on. What is going on? Is it alarm coming to me? Is it right? Wrong? Someone's trying to attack my network. Should I fix it? Should I allow it? Should I block it? They have access to block the access. Let's say you are sitting in a SOC. You sometimes have access to delete the user or block the user access and do something, right? Because your job is to protect your company's assets and network, right? So security operations center is a team who's monitoring all the time, and that's the fancy thing that you see in the movies, big screens, alarms coming, and like this is what it happens in real world. SOC is a very, I would say, well respected job, very technical job, and that's where you are monitoring and you're fixing the problems that company can see. Yes, Mohammed Omar, what do you have? You have something?
I had the same question. Okay. I also have a confusion if there are a lot of alerts. So how they manage it?
Yeah, it's a good question. Again, there could be a lot of alerts, right? It could be hundreds and thousands of alerts in some cases, but it depends, right? A lot of companies have more SOC staff, but now it's changing, right? In old days, they used to hire more and more people when they see more alerts, but now it's getting better, it's getting easier with the help of artificial intelligence. AI is making it easy because now AI tools are the one who do a lot of human thing. The before human used to investigate the alerts. Now AI tool will do the basic investigation, and maybe it will tell you that yeah, it's a right alert, it's a false alert, it's a true alert, right? So maybe you get 100 alerts, out of 100 maybe only 10 are worth investigating, right? This AI tools are making things easy now. So alert volume, and this is again the situation where your alert, you should get the right alert, you should not get the false alert, right? So that's where the job of the SIM tuning or optimization comes, that SIM has to make sure to set up in a way that it should not generate false positive, it should not generate the unnecessary alerts, right? So this is again a mix of a lot of things, the SIM fine tuning, the way SIM is configured. And if you're getting more alerts and all the alerts are valid, then you use AI to see which one are critical, which one are non-critical. So in the end, when the SOC analyst, because SOC analyst is a human, and this human is a very precious resource. Human has more capability than machines, right? Intellectually, humans can process things in a better way than machines. So only the legitimate alerts, or the alerts which are needs to be looked into, are the one which are filtered by the AI, and SOC analysts will look at it. This is the way industry is going. Industry is going towards AI to be used in the tools to reduce your alert volume, and only right alert, because a lot of time in today's world, a lot of SOC analysts are wasting time in investigating the alerts which are not valid. They investigate, they spend their time, and oh, it's a false alert, it's not the right thing. So that's where AI is coming to help us. I hope it's clear now.